My name is Laurent Doguin. I'm a French developer advocate based in Paris, in France, and I work for Couchbase. I would love to do a show event, but the light wasn't off. But if you guys can scream when I say, when you actually have heard of Couchbase. Do you guys have heard of Couchbase before? Can you scream for me so I can actually hear it? Good enough. Has any one of you heard of RxJava and Ratpack before as well? Few of you. All right. That's cool. If you guys have more questions after the talk, you can follow me on Twitter. You can send me an email. The slides will be online at one point. And without further ado, let's start about Ratpack. If you guys Google Ratpack, you're going to find this, on Google. So you should Google Ratpack framework or Ratpack web, because Ratpack was actually an active single club in the US in the 60s and 70s. So make sure you actually Google Ratpack web framework and not just Ratpack. And if you Google Ratpack web, you'll find this, which is an AT-based full-stack non-blocking web framework. I'm going to talk more about what it is in the next slide. So it has several interesting characteristics. First of all, it's a fully asynchronous non-blocking framework. It's built on top of Netty, which is a network stack, async non-blocking network stack, which is the base of, if I'm not mistaken, Vertex as well, and Ratpack, and many other very cool reactive asynchronous non-blocking pieces of software. And it's really nice. It is opinionated in a sense that it will let you do anything from a general web programming perspective. It is opinionated in the fact that it's going to force you, or not force you, but if you're doing Ratpack, it's to do asynchronous non-blocking code. And what it looks like is, it looks a lot like Vertex web, because Vertex is actually non-blocking. Vertex looks more like Node.js. On the server side, you could do many, many, many things that don't really have to be web. Ratpack is kind of a specialized Vertex or Node.js for the web. So it's a full web-oriented framework. It is really good for that. It uses promises. If you guys did some JavaScript before, you probably encountered promises. It's how you do callbacks, basically, in JavaScript. Or here in Ratpack. Based on Java 8, there's a very good reason for that, is that when you write asynchronous code, usually you end up writing callbacks, and a callback is an anonymous function. And in Java 7, if you want to do an anonymous function, then you write the whole class implementation just to write a single function. So Java 8 brings us lambdas, so it makes sense that everybody uses Java 8. It also has a very good integration with Groovy, because most of the people that wrote Ratpack are Groovy people, and as such, there's also an interesting Gradle integration. Now, why would you use Ratpack over traditional web framework? And more precisely, why would you go async non-blocking instead of traditional stuff? And the reason is most of the application today, web application, are usually I/O bound, which means that the bottleneck will be either disk or network. Usually it's not the CPU. And it's not memory. Memory is cheap now, so. This is a good example of why async non-blocking are interesting. This is a traditional, on the top, traditional request. Let's say using Tomcat. The request goes on a thread. The thread takes the request, does a bunch of stuff. Sometimes some I/O stuff, like writing to a file, calling a database. While it does so, the CPU doesn't do anything. Basically, the CPU stays here and waits for things to happen. Well, it could be doing something else, but it doesn't matter because you have this synchronous thread model, which means that each request you send to the server will be treated like this. I'm going to treat the thread is going to treat the whole scope of the query, of the request, sorry, and it's not going to do anything. If you do a database call, it's going to wait for the network to send you back the answer, the full answer, and once it got the answer, then it can resume and keep on sending you stuff. The asynchronous way of doing things is a little different. Instead of having 2002 to maybe 200 threads on your Tomcat server, and in that sense, you can only handle 200 requests at the same time. It uses an event loop, so it's 2, 4 threads, depending on the number of CPU and core you have. And what the thread does is take the request in. It knows for a particular request that it's going to go through all this code, put that in a stack somewhere, and then the thread is available to get another request, which means that the CPU won't be doing nothing. It will actually keep on handling requests, put all the I.O. stuff on the side on another thread. Once the I.O. thread is done, once all those I.O.-bound processes are done, it goes back to the event loop, and then the response goes back to the client. And in that way, your CPU doesn't do anything anymore. It's not waiting for something to happen. Now your CPU is actually working and doing stuff, which is better. There's a lot of interesting talks on the internet where people actually run reactive async non-blocking application on Raspberry Pi, and they can handle much more requests than a traditional application on a traditional server, which should give you an idea on how cool it is. So to talk more about Ratpack, this is the Hello World example. It's extremely simple. It's the main of your application. There is no containers. You don't build a WAR, you don't build a jar, you don't deploy anything in a container. That's just the main. You call the start method. It's going to start a server, which is basically a netty process, a netty socket. And in a server, you declare handlers. A handler is, for this portion of URL, I will do this code. A handler is the class that, where you write the stuff that happens. And what I'm saying here is I have a chain of handlers, and I'm doing something very basic. So for every request that comes to the server, which is chain.all, I take the context object, and I render a string called hello world. That's the hello world example. No containers, really simple. Could be a nice one-liner. And again, it runs in the main, no Whitefly or no Tomcat or whatever, just pure, easy Java, which is nice. The context object gives you the request, the response, and a bunch of other stuff we'll see as we go. It has a nice module system, not really plugin, but more about modules. The difference I would do with plugin and modules, usually when you have a plugin, you write a plugin for something that's been designed to be extended. So if you come from the Eclipse world, for instance, you write a service, and in the service you define an extension point, and this extension point say, I can only register plugins that are like this and that do this very specific thing. That's a plugin framework. A module is more, think of it more as a decorator, when all you do is add a behavior to existing code, which is much more easier and interesting, especially when you groovy and you can do some interesting magical thing at runtime. The injection is based on Juice. Juice is the Google dependency injection framework. It's pretty basic. Basically, you instantiate everything at the beginning, put everything into your data structure, and then when you need it, you just do a get, and you get the instance of what you asked and what you instantiated before. You don't have to use Juice. You can use Spring Boot. If we have time, I will show you an example that uses the Spring Boot application, but instead of using the traditional MVC part of Spring Boot, I'm using Ratpack. It's interesting with Spring 4 because Spring 4 is not designed yet to do asynchronous non-blocking stuff. Spring 5, on the other end, which is coming in 2 or 3 months, is fully based on Reactor, and Reactor is a new reactive project by the pivotal guy. It's really cool. And so all the Spring 5 framework will be asynchronous and non-blocking. So it's going to require everyone to kind of do a switch of mind between synchronous blocking to async, and it's for the better, I assure you. So why would you do Ratpack compared to other stuff? Well, I said it before, basically, you spend too much time on I.O. and your CPU doesn't do anything. It's bad. You could actually use that if you go non-blocking, and that's why it's really cool. And the other interesting thing is that when you do asynchronous non-blocking code, it's really hard to debug. It's really hard to understand what's going on. With Ratpack, the way it's done, it looks almost, well, it actually looks like a deterministic synchronous execution. You don't have all this callback of future hell. And one of the interesting frameworks that exists in the world right now that are stable and that allow you to do async non-blocking stuff with Java is RxJava. There's also Reactive Stream and some others, aka in the Scala world. In Java, most of the people use RxJava. And why did they came up with RxJava? Well, it's here to fix several things. The first thing is blocking is bad or evil or whatever. You know, when you block, then some pieces of hardware don't do anything. It's sad. It's very sad if you think about the carbon footprint of your computer, because they just, you know, sit here, eat energy, and do nothing. So you could be faster. And also, async is great to be reactive, to be polarizable, composable, and readable. I'm going to talk more about all of this during the talk. But you're going to tell me I can already do reactive stuff. I can already do asynchronous stuff. You can write callback in Java. It's true, especially in JavaScript. You can also use Future in Java. The Future API had a very, very bad reputation because you have a feature of something, there's a get method, and usually what people do when there's a get method on an object is call the get method. And what it does is block. So you could block so easily that it was really hard to use, and it's also really hard to compose because you cannot do one feature that calls one feature that calls one feature that calls one feature easily. If you Google callback, you'll find this on Google. It's callback hell. That's a good example of how hard it is to read async nested. That's what I was doing for nested code to do nested operation. It just looks like this. I'm doing something. When I have the answer, I'm going to do something else, etc., etc., etc. Really hard to read. Sad. So RxJava is trying to fix this problem. It's been brought to the world by a company called Netflix. Netflix used to be a company that sent DVDs using the postal service. So you could actually rent DVD at the very beginning of Netflix. Now it's a streaming company, probably responsible for 20% of the traffic in the US, the 80 other percent being porn. But that's pretty much what they do. And they really needed to scale, so they put everything in Amazon, and they had several issues coming up. And using the reactive way, using the reactive pattern, allowed them to fix most of the problem. It was really easy to do composable code, to do asynchronous code. I'll talk a little more about this later on, but what it really is move from a pull model, iterator and iterable, to a push model, which is observable and observer. An iterator is just a big byte array of stuff, and when you ask for something, you wait. If it's a database, for instance, it's going to send you the whole byte array once it's done, once it does the query, send you everything. And once you have everything, which is when everything has go through the network, you can start calling next to get the next element. And observable is different in the sense that it's a stream. It's the database that pushes all the new elements directly to you. So you move from a pull way of doing things, which is calling next, to a push event-based model. When there's a new object coming up, there's a method called onNext. All the methods in observable are on something because it's, again, event-based. And that's really interesting. It allows you to do really cool stuff. So why reactive? Again, Netflix, they had to react to an insane user load, especially elastic user load. Let's say there's a new episode of, well, not Game of Thrones because it doesn't, I'm not sure it's on Netflix, but of a new, very cool TV shows. Everybody logged in at the same time. You need to make sure that everybody has access to video, and then after 1 hour it's gone. So you need to react to that user load in the sense that you have to grow, sustain that load, and then grow back smaller because you don't want to have all those machines that don't do anything. You have to react to failure. It is very important when you are distributed. All the distributed systems that tell you nothing's going to happen, it's fine, it's really cool. It's not a good distributed system. A good distributed system will tell you if something fails, because something will fail, it will be handled with grace, and it's going to be nice, and everything's going to be okay. A good distributed system assumes that something's going to be wrong at one point. And what is really cool about the Netflix guy is they were running everything on Amazon. Problem happen on Amazon sometimes. Some would say often. And so what they did was create this thing called Chaos Monkey. Well, they have the Simian Army now. And the Simian Army, it's all those programs that basically brought chaos to all their machines on Amazon. So because they were assuming that anything could fail at any time, to make sure that they were resilient, to make sure that they could react to failure, they basically had this Chaos Monkey thing that would turn off machines randomly. And by doing so, they programmed the system to make sure that they could still keep on streaming stuff to you while you were watching it, even though you had a crazy program that was turning off machine. So they know how to react to failure, and part of it is because they use Reactive. So yeah, they needed some new solution, and RxJava and being reactive is part of the solution. And really the bulk of it is the latency is too high, which is there's too many people doing query, and then there's too many systems that are just doing anything, not doing anything, just processing I/O stuff, while they could be doing something else. And this is what being reactive, like using RxJava, will allow you to do. So I'm going to do a very gentle introduction to RxJava, and then we're going to talk about code and a little bit about Couchbase, because that's the database I'm using for my example, for my code, and that's also our SDK is better on RxJava, so that's part of the example I will show you. So the synchronous way of getting an object usually is T. So it just gives me T. If it's a list, gives me an iterable of T. If you want to do the asynchronous version from Java 7, you are getting a future of T. If you want to get multiple asynchronous objects, you can get an observable. An observable is a stream, so it's just going to be a list of stuff that goes through that stream. That's pretty much what it is. So you really go through, again, that pull-to-push model. If you have an iterator, you ask for next. If there's an error, you throw an error, and then everything stops. And once it's done, you return the answer. And observable, again, everything starts with on because it's event-based. Every new object that comes up through the stream, there's going to be an event, and you can listen to that event by implementing those three methods. The most common event will be on next. There's a new event on the stream. What do you want to do? Sometimes error happens. If there's an exception, what do you want to do on error? And once the stream is done, you call the uncompleted method. Sometimes you have infinite streams, so uncompleted will never be called. That's a little more advanced, so I won't talk too much about this today, but in case you were wondering, it happens as well. So this, hopefully, is big enough. A bucket is where we store documents in Couchbase. I'm asking for the asynchronous facade of that service, because we know that people are not really familiar with asynchronous and non-blocking, so by default, the service is blocking. But I want the async method, and then I do a get, and what a get does is, with the idea of a document, ask the database, so that's an I/O operation, it's network, gives me the result. If I stop to bucket.async.get something, nothing happens at all. I have just described an observable, and I have an observable object, and once I call the subscribe method, then something happens. So it's interesting because if you have observable all around the place, you describe lots of stuff that could happen, but at the same time, nothing happens, which is nice. And I'll show you why in the next slide. And so if you subscribe to something, you describe what happened on next, on error, and on completed. It's a cold observable. We have some hot observable. This is not, again, something I will talk about today. A cold observable is an observable. Once you subscribe to it, it starts moving things through the stream. A hot observable is something as soon as you declare it, some stuff are going through the stream. If you subscribe, it won't restart the stream from the beginning. It's just like a hose, basically. Everything comes up anyway, and once you subscribe, you get the new stuff. It's really handy to, for instance, use the Twitter API. They have an ongoing stream of tweets. You probably wouldn't want to do a cold observable, which is give me every tweet from the very beginning of the Twitter history. I'm pretty sure it couldn't even be done. So they use a hot observable, which is get all the new tweets starting from the moment you subscribe. That's the difference between cold and hot. In Couchbase, every observable are cold by default. So how do you create an observable? If you Google RxJava after this talk, you will find a lot of diagram like this. It's a marble diagram. What it does is tell you, I have some stuff at the beginning, I call an operators, and then I have something else. At the beginning, I have an array of things. I call the just method, and I have an observable of elements that were all the elements of my array, which is pretty much what you see here. An observable has a static method called just. Give it as much parameters as you want. Again, if you don't call subscribe, nothing happens. The moment you call subscribe, then it starts printing everything. It is fully asynchronous, so it could very well be ACB instead of ABC or BAC. No, it is async. Another operator is called interval. I'm going to go through a bunch of small operators just so I get a feel of how it works. An interval basically is every second, every minute, every interval basically do something, which is basically it's going to do 0, then wait for 2 seconds and send you 1, and wait for 2 seconds and send it 2, and blah, blah, blah. There's also a method for creating observables on next, on complete. Basically, it allows you to create your own observable without having to pass an array or do a call to something else. So what it is really is just an implementation of a subscriber. What happens? You can yourself call the onNext method, the onCompleted method. It's really more useful for people that actually write observable operators than traditional people or traditional users, like traditional developers, sorry. That's one of the most important operator you will have in RxJava, and you probably know it if you already do functional programming, or if you played with the Java 8 streams, or if you played with Reactive stream. What map does is take an element, apply a function to that element that transforms it and then returns the result. In terms of coding, if I take my RxJava example again, I have my bucket, I get the documents, and the document in Couchbase is, there's an ID, and then there's the actual JSON value and a bunch of metadata. I don't care about the ID or the metadata. Actually, I already know the ID. That's why I asked the document. So all I need is the actual content of the document. So I have, after get, an observable of document. And after the map, instead of having an observable document, I have the content of my document, which is the JSON part, which is what you see here. Again, if you don't call subscribe, nothing happens, and you just describe a function that will be applied to the event, the element of your observable once it happens. So it really allows you to describe a flow of applications without actually executing anything. This is a little bit different. It's called a flat map. Again, you probably know it if you do functional programming or if you do Reactive stream. What a flat map does is there's an observable of stuff coming in, and this function will transform this object into an observable of something else, and at the end it will map all this observable of something else to a single observable of something. So I have one circle, and I apply a function that transforms that circle into 2 other shapes. The red one comes in, it transforms everything, it's fine. And then the green one, the blue one come very close very soon. Again, as it's synchronous, you won't get necessarily the 2 green and then the 2 blue. You might have 1 green, 1 blue, 1 green, 1 blue. It is async. You have some function that allow you to make sure everything is ordered, but by default it's fully async, so you don't have deterministic order. And so the circle, the flat map transforms the circle into an observable of 2 shapes. So the first observable will result into 3 observable, 1 for each circle that goes in. But at the end, because I'm using flat map, it just returns 1 single observable. I mostly showed you key value get. Of course, Couchbase is a database, so you can actually run a query. And when you run a query, you have multiple documents. So here I'm doing a query, gives me every beers by name, limit just by 100 beer. And then I get an async result. An async result gives me rows. I will flat map all those rows into a particular document. And once I have the document, I can use a filter function. And what the filter function does is get the content of the document, get the property called ABV, it stands for alcohol by volume, and just returns every beer that have an alcohol by volume superior to 5. That's way it works. Then it counts it. Then we apply, and that's the first time you see it, a timeout, and that's extremely important. And then once you call the subscribe, runs the query, and then send you the result as it goes. I'm saying the timeout is important because you can actually, on a very long flow of information, declare a global timeout. If you try to do this, you would have to get the query result, then to wait for all the result to happen, then to do a loop, then to create another structure, and then while you're looping through all the beers, add something to the other list, and then return the list.size. If you want to time out all these operations, you would have to run this in a thread and then handle the timeouts directly in that thread. I mean, try to imagine this the traditional Java synchronous way. It's really hard to declare a total global timeout on all these operations. And what it allows you to do is declare a global timeout, and that's really nice. Another observable called group by, what it does, it's quite nice as well if you handle a lot of data. I have some documents stored into what is called a beer sample. The beer sample is where I store all my beer and brewery documents. So I have two different types of documents. And by doing a group by, I'm saying group everything using the field called type. So in the end, I will have a structure that gives me a map, and the key of the map will be the value of the type. I only have beer and brewery as type in my bucket, so all it gives me is a structure where if I do get beer, it gives me the list of beer. If I do get brewery, it gives me the list of brewery. So it's a single traditional group by, as you would do in a SQL query, but instead of doing a query, you do it with an API. You can also do a buffer. The most interesting example of showing a buffer is actually showing how it works. So every 3 seconds, nothing happens. I buffer stuff coming in, and then do a spike, do everything, wait for 3 seconds again, do some stuff. That's what you can do with buffer. I already talked about the filter method, which allows you to filter based on a function that returns a Boolean. This is the first time I'm not using a lambda, so this is why you can see Java 8 is quite nice when you use RxJava or any reactive async stuff. It's really nice because this is much more verbose, and this is maybe not something you want to write all the time. But the good thing about this is that actually, I think it's really nice to have the signature of the function you're trying to implement, especially when you're starting using RxJava. Because now, if it forces you to know what type you are returning, it's always better. So you can see that a flat map takes an element of the observable, and each time there's an element, it applies a function to that element and return an observable of something. That's what a flat map does. And you can see that the filter returns a Boolean, which makes sense. And something I haven't talked to you about is there's an observable coming in either if I do a query that's supposed to return multiple documents at the same time, or if I do a get that's supposed to just return one document. It's always an observable, which is weird because traditionally you do a difference between having a single object or a list of objects. Unfortunately, this is not something you can do with RxJava, but the people from Reactive, the people from Aka, I think, and the guys in .NET as well have a way to declare a single observable, which is an observable that will return just one thing, or an observable that will return a stream of stuff. So if you just want one object from that stream, you can call the first method. And that's actually a nice example when you use a distributed system. Most of the distributed systems have replica. So if you want to get the doc document, and it's not available because the active version of that document was on a computer, and that computer is not available anymore, then what you can do is do a get from replica, which is give me an answer from all the replicas there is. Maybe you have just one, maybe you have 4 replicas. In case you have 4 replicas, it's going to ask the 4 computers that each one holds one replica. But you don't really want to wait until all those 4 queries gives you an answer. You don't care, you just want one replica. So that's what you can use first, actually. Get from replica will return to you an observable of several replicas. All you want to do is get the first one. Of course, there's another bunch of operators like single, like toList. toList is actually a blocking operators because what you're doing is basically waiting for all the events to happen, and then on complete, you can actually put everything into a list and return that list. So if you don't know RxJava right now, you should be feeling a little bit tired, maybe, or weird, or whatever. So this is just so everybody can relax. Hopefully you don't have too much question. I have 18 minutes left, so I'm going to quickly talk about Couchbase and then show you some example code that I use in Couchbase. That's an application, but I'm not going to talk about it. Couchbase is a distributed database. There is basically 3 front service. The data service, when you write something, it goes into the data layer. When you do a query, it goes to the query service that execute the query through the index service. Pretty basic stuff. Everything you do starts in memory, which is why we have a cache layer. Then it's stored to disk, which is why we have a storage layer. And everything is masterless, so we have a cluster manager on each node. You don't have to do master, slave, and controller, really. Just one node does everything. And of course, there's replicas on several nodes. What happens when you have too much load on your small 3 server clusters? Well, what you do is you add 2 nodes to that cluster, exact same node, no difference between master, slave, and controller, just add 2 nodes, and then trigger an operation called the rebalance, which basically redistributes everything evenly. And you can see that some documents are active and some are replicas. What happens if the node in the middle falls down? Then the active version of one document is not available anymore, but it's still available on the replica. So if you think about the function I showed you before, the get from replica, what it does is actually ask every other node for a replica, and then gives you an answer. You have to specifically ask for a replica because a replica might not be up to date, which is why we want it to be a developer operation. So you have basically 3 ways of querying data. You can do key value, you can do views, which is basically a materialized view like you would have in SQL database, or you can do a query using Nickel, which is an interesting SQL language. It's basically select or insert or update on your JSON documents. It's the only database that allows you to do that. You can do join as well. You don't have to install Spark or Drill or anything else. You can do join out of the box with Couchbase. I'm going to go quickly through another example, and then I will show you code. What's really cool about this is how you manage errors. Timeout is part of this. It's really important to say this operation should not take more than this much second, because you're in the distributed system. Things bad could happen. Make sure you set a global timeout. Another really interesting thing you can do when you do RxJava stuff is use a circuit breaker. Netflix has this very nice project called Hystrix, and what Hystrix allows you to do is basically declare a circuit breaker. You have 2, let's say you have 2 web services. One is free and extremely unreliable, and one is cost you money each time you call that service, but always return an answer. So what you could do is use a circuit breaker so that each time you do the call to the free service, if the free service doesn't answer, there's an error, you put the circuit breaker on and it redirects you to the paying web service, because you don't want to call it by default because it's expensive. And with this trick, it's basically just adding an annotation and saying, if this method doesn't work, go to this method, which is quite nice. It also allows you to handle back pressure. And what back pressure is, which you might not see here, sometimes you put too much load on a service, or especially on the database. If you put too much load, then you cannot process stuff coming up anymore. So what Couchbase will do is send to the client a back pressure exception, which basically says, stop, I cannot write anything anymore. There's too much people trying to write stuff at the same time. Please do something. And once you know that you have this, you can do interesting things like exponential backoff, which I should have an example soonish. Where is it? And then I will show you the code. There you go. Last interesting slide before the code. It's not properly an RxJava function. It's based out of the Couchbase SDK, and what it allows you to do is declare what you want to do when a back pressure exception or a temporary failure exception occurs. Basically, you say retry when this exception occurs, and then declare a delay. The delay here is of type exponential, and I'm going to use it 100 times max. And what it says is, I got a back pressure exception. I will retry in 5 seconds. If I get another back pressure exception in 5 seconds, I will retry in 10 seconds. If I have another back pressure exception, I will retry in 15 seconds, and it's going to do this in 100 times. Now, I will let you imagine how you write this in traditional synchronous Java code with thread and try-catch and all this kind of stuff. And right now, you should be as bored as me because no one wants to imagine that because it's too complicated. All right, I have small bits of time to show you code. Apologies. I'm going to start by that application. It's a nice one. This is an RxJava application that just declares a RESTful API that aims at storing user. And it's using RxJava and Couchbase. So what I do here is initialize the Rx Ratpack module. Rx, you need to initialize stuff because you need to initialize all the thread pools that are going to be used. Then I start my server, and I'm declaring a configuration in the registry, and what the config does is basically use juice and instantiate a bunch of stuff at the beginning that will be available in the context. So what it's saying is declare a cluster connection, declare a bucket connection, which is where I store stuff, and then bind it, which is to say put that instance of an object inside my context so that I can retrieve it whenever I want. I will also bind 2 interesting classes, user render and user renderer, which we're going to see in details. So where's it? It's here. So once I've declared my modules, all my config, I declare the handlers. If you recall the first example I showed you, it was chain.all for everything that happens, returns hello world. Here, when the request is a URL that starts with user, then please go to user handler. And the user handler starts by checking if it's user/something. All the URL are based on the regex. All the regex are described, all the syntax is described on the Ratpack documentation. And basically, if there's a user ID, user/something, then you go to 3 possible HTTP verb. First, I get the actual second part of the URL, what is the user ID. I get a repository out of my context, which is one of the class I binded in my previous configuration, and then I can say, using the context for different HTTP verb, what's going to happen. If it's a get on user/someone, then what I'm going to do is get my repo, get the user ID, get an observable of object, and then render that object. This service returns an observable. Ratpack uses promises. There's a very cool way of saying if an observable returns one single object, then I can use the promise single, and I make sure that once I call this code, this will actually be subscribed. The query will go to the database. The user will be eventually returned. On the onNext method, it will be mapped into a single user and then go on the then part of the promise, which basically allows you to do something once it's over. And what I'm doing is render the actual user. If you do a get, you return an object. If you do a put on an existing object, basically you modify it. So if you modify it, there's probably a form or a body request. How do you handle a body request in Ratpack? Again, from the context, you can call the parse method. And basically here you're saying, let's parse the content of that request to a user object using Jackson, and I get a promise of user. Again, it's the same deal with observable. Nothing has happened. It's still a promise. The code might not be done yet. I'm using Rx Ratpack because you can map a promise to an observable, or you can map an observable to a promise. So here I'm mapping a promise to an observable. Once I get my observable, I can ask my repo to create the user, to update the user, sorry, and once it's done, I can render everything went well, I can render OK. There's a delete method, you get the ID, and if there is no second part of the URL, like user, it's just /user, and it's not about one particular user, basically means you want to either create a new user or retrieve the full list of user. The first example is get the full list of user. Again, I use by method to know what's going on. If it's a get, then return the list. By returning a list, what I'm doing is doing a basic SQL query. It looks a lot like SQL. It's actually querying JSON documents, which is, again, very cool. Get the result, map everything into a JSON object, create a new user, and then, in the end, as well, return everything in a promise. And if it's a post, basically does the same thing than the put, but this time you have to create the ID of the user because it has no ID yet. An interesting thing is that the render part doesn't assume anything about the content type. When you do a request, you can set up a content type that basically says, I'm expecting to receive some text, I'm expecting to receive XML, I'm expecting to receive JSON. So when you do render a user, what it actually does is go back to my config, go through what is called a user renderer. In Ratpack, you can declare a renderer based on an object and a content type. Just as we had the by method before, so the get, put, post, etc. If you want to be RESTful, if there's a content type, you don't want to return the same thing all the time. So you can define something by content. If it's JSON, then you return a JSON value. If it's text, then you can return to string. And JSON and plain text are some default content types that are registered, but of course you can return any custom content type you want. So that's pretty much how you do a RESTful API in Ratpack very easily and very quickly. There are some more interesting examples. The one I wanted to show you was the one that I broke by moving it to Spring Boot, but that's fine. I'm going to show you it anyway in the next 6 minutes. This is an application that allows you to store file. And if you're playing with file and database and you don't have everything using observable or promises, usually what you end up having is some services that do blocking code. And we said before that blocking was bad and everything. So how do you deal with traditional blocking code when you do a Ratpack application? Let me find the right example. Data extraction service, that's the one I was looking for. When someone uploads a file in my app, what I do is actually persist the file on disk and then run a command from the file system, which is using a tool called exif that returns a JSON of all the metadata of the file. So what it does is persist the file, run a command on the system, and then get me the answer. This is absolutely fully blocking and synchronous. So all you have to do is wrap this into an object called blocking, which is a Ratpack object. And what this will do is return to me a promise. And once you call that promise, then it runs all the blocking code. And everything is nicely retrofitted into the Ratpack model, which is very nice. So you can actually easily migrate existing application to Ratpack by using blocking. I have 5 minutes left. If you guys have any question, I'll gladly take them. If not, I can keep on showing you other stuff. So if you can turn on the light, or maybe you guys can scream the question and I can try to answer them. No one screaming, that's fine. I will show you more stuff for the next 5 minutes. Blah, 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 blah. I have somewhere an example of error treatment. I have another example of error treatment that's nice. Here I have my document. I'm creating the document. I'm upsetting it. I'm saying here, this whole operation shouldn't take more than 500 milliseconds. Fair enough. And if something happened, like a request cancelled exception, this could happen because you have a crappy network and you've dropped some packets, but that's fine. You can actually declare a delay and retry every milliseconds. If it's temporary failure, you can do another kind of retry. This is really nice because, again, try to imagine how you would do that traditionally with maps and stuff like this. It's pretty hard. This is another cool example. I'm saying, get me that document. If that document doesn't exist, there's an operator called switchIfEmpty that allows you to do something else, which is basically try all the replicas and then get the first method. That's, again, the other thing I showed you before. So that's a traditional example in very simple application that can give you an idea how you use RxJava in a web application. I'm not sure I have more interesting example. It's pretty simple. I can talk a little bit more about Ratpack. If you want, you can use different modules. There's different templating modules, and one of them is handlebars. So how do you use handlebars? When you render something, if you don't have a user renderer like I implemented before, you can actually declare another rendering method using a template.handlebars template, because I've registered my handlebars module, and what it does is fetch in the template folder a template called upload form. You say it's going to return text content type text HTML, and the answer in the rendering context of handlebars, you can put the answer of your promise. That's pretty easy. How do you declare a module in Ratpack? Well, it's quite nice if you use Gradle, because again, it's very well integrated with Gradle, because it's Groovy people that did this. What you do is first declare a Ratpack module. You're saying here, I'm using Ratpack, Gradle, the plugin build. And then when you want to add a module, you do ratpack.dependency, the name of the module, and it will add everything automatically. If, for some reason, the current version of the modules you want to import are not the one you want, then you can still declare it by hand, which is what I did here. I was using the latest version of Spring Boot because it provides autoconfig with Couchbase, so I had to declare this manually. But actually, this could be replaced by just this. That's pretty much the same thing, minus the handlebar stuff. So you could actually just do this. So it's fully integrated with Gradle. I think that's pretty nice. No messy or too messy version management, and that's how you handle dependencies. "45 seconds left, still no question. Please shout if you have a question. Okay then. Thank you for joining this talk. Hopefully I did not bore you.